Hello everyone and welcome back to Arctic Retro. In today's episode I'm going to take a look at this machine. It's a very sad looking VIC-20, Commodore VIC-20 that I recently got, and yeah, if you saw my mail and donations video last time, you saw me unboxing it and testing it a little bit, and it didn't work at all. So in this video I thought I'll take a look at it and see if I can repair it and get it working again. As you can see, it's very dirty, or maybe you can't see it, but it is, and quite yellowed. It's supposed to be white, but it is yellowed. So this is a kind of an early model. I think it has this rainbow VIC-20 logo. The keyboard is not the early one with the PET keys, but if you take a look at the back side, it has a quite early serial number 63357. Exactly what kind of motherboard is in it, the revision, I don't know. I have to open it first. First issue was this old power supply brick. It didn't work, but it didn't work because it's missing the fuse and the fuse holder, so I'm not sure if it's broken or just missing. I tried to find a fuse holder that could fit, but I couldn't find one. So I actually just decided to cut the cable. It is that two-prong power connector. This one, and the power supply is only 9 volts AC out. This video is sponsored by PCBWay. And I just want to thank them for a great cooperation and for their support. They make prototype PCBs of very good quality, and they also do 3D printing, and they actually helped me with printing this case for this beautiful 1581 floppy disk drive replica. And they also produced and provided me with this PCB for the 1581 floppy disk drive. Even if you don't design the PCBs yourself, you can visit PCBWay's shared project site, and here you can find a lot of ready-made designs which you can just order directly from their website. And right now they have started with the PCBWay 7th project design contest, where you can participate with your designs and win great prizes. So please check out PCBWay for all your hobbyist project needs. So I actually just found a 9 volt AC power supply, and I took the connector from the original one and spliced it to this one. This is a modern power supply. It's quite much lighter and smaller, but still it has more watts out from it, or amps, volt amps when it's AC. Yeah, there are several issues here. As you can see, the space bar is missing, but I think I have a spare. And when I pulled out the power, it actually took the whole power contact with it, so it's kind of loose. Just push it back into there. Yeah, it has a different kind of power switch than the later models, and the later models had the same DIN power connector which the Commodore 64 has. User port, it has a cassette port, it has a serial port and a video out, a composite video. This machine doesn't have an RF modulator, which the Commodore 64 has. For this one you had to buy a separate RF modulator to connect to the video output. I'm not sure if that came with the machine or you had to buy it separately. And also it has the cartridge slot. And you can see here it's kind of loose, the cover. So several things to be done, and on the back side it's not that yellowed, it's yellowed over here, but this one is more like the original color. So I have tested it and it did not produce a video signal. The power LED came on, and let's test it again. Yeah, and now the power LED doesn't come on, so I guess janking out that power contact actually damaged it. But that should be an easy fix. But there was no signal from it, not even a black screen, so I guess there are more faults with this. I also got the Commodore cassette recorder, and it actually had a tape with some games. VIC 20 games pack. It has Alien Blitz, Invaders, Ground Attack Storm, and Space Rocks. So I hope this one too works and that we can load those games. I don't think I have ever seen those before. Yeah, when I try to pull out the power cable, the connector just comes with it, so I guess it's kind of broken then and needs to be fixed. Just to check that the power supply is okay, yes, it's 10.6 volts AC. Yes, let's open this up, and yeah, the power contact just fell out, so I guess I janked it out when I tried to pull out the power cable. Oh boy, it's dirty and there are loose parts inside. Hopefully it can be fixed. Hopefully it's not a total wreck with missing parts or anything like that. Seems like it has been opened because screws were quite loose. Well, let's see what this thing is hiding. Okay, looks good so far. Okay, the motherboard is loose. Missing screws. Keyboard looks to be intact. It smells kind of bad. Okay, yes, all the chips are there. Alright, so I'm taking out the motherboard. I unscrewed the 3 screws that were in. I found 2 other screws laying loose in the case. Yeah, quite dusty. So maybe it was dropped to the floor and thus the screws came loose, but I'm not really sure what happened. Yeah, I'm gonna clean this up before I do any retro brighting on it. Just gonna remove the keyboard as well. Yeah, these screws, they crack, so they have never been taken out, I think. Let me take a closer look at this motherboard. Everything looks alright. All the RAM chips, they're not in socket. Here's 6502 CPU, the CIA chips. 6561 is that VIC chip. And then we have 2 ROMs here. And a big 4700 microfarad capacitor. There's a fuse. I'm going to check that quickly. First thing to check. Yeah, it's good. Yeah, here's that poor power connector. Just ripped right out. I'm thinking maybe I should replace it with the more modern Commodore 64 type. But for now, I'm just gonna install it again, and yeah, I'm gonna solder it back. Not really sure how it was. Was it like that or like that? I think it was like, no, those point downwards, so I guess they were just soldered in. And then this is just pushed in, but it looks alright, but it still doesn't hold very well, so yeah, that's a weakness, I guess. I'm gonna remove these shields, heat sinks, they're just screwed in. What's that? Is it a voltage regulator or a transistor? Not really sure. Yeah, maybe I'll just leave that. And then we have this bodge that goes between this side of the board and the other side. That component is also soldered in, so I won't get this out Well, of course I will. No, I won't. I need to desolder this to get this out. I don't want to do that. So just use a little bit of flux and remove that old solder. Dust. Yeah, that's enough. Clearly there are holes for using a regular DIN connector. I think it's like a 7-pin, but they decided to use this one instead. Just gonna solder in those. Well, those are kind of big holes. Needs a lot of solder to fill those. So that's it. Just push it in and hope it stays. I just need to be more careful when I pull the power cord. I'm pretty sure this was not broken when I tested it before, because there were light in the power LED. But I'm gonna test it anyway, turning it on. No, there's no signal. Okay then, it's time to check for voltages. Yeah, let's check the LED connector. Yeah, 3.3 volts, that's correct. And let's check some of the chips. .2 volts on the chips. That is not good. Yeah, the cassette also has just 3.1 volt. So we have too low voltage, but we have voltages at least. Guessing it's this one then. How about the bridge rectifier? Yeah, that's more correct. That's 4.8. Still a little low, it should be 5. The rectifier is quite warm. Yeah, very warm. More than usual. So this is the voltage regulator. It's SH323 and it is supposed to give out 5 volts. Here's the data sheet for it. It actually says 5 amp 3 volt, but that must be a type error, because here it says it's a hybrid regulator with 5 volt fixed output and 3 amps output capability. Let me just measure that voltage regulator and see what it gives. Okay, it's 3.1 volt and the other pin 4.7, but we saw just 3 volts on the chips. So if I have the machine turned off, yeah, then we have 10.6. As soon as I turn it on, it goes down to 5.8. So there's something there that makes the voltage drop. Looking at the schematics of the power input, there isn't much going on. You have the input jack and a couple of capacitors, coils, and yeah, directly to the bridge rectifier, which has 9 volts AC in, and then it should have 9 volt unregulated out, which is obviously doesn't. But I realize now I might have been an idiot here. This power supply, it can only supply up to 400 milliamps, and that's not a lot, is it? How silly is that? Maybe it's the power supply that's actually too weak. I'm gonna solder in the regulator again, and yeah, I'm just gonna try and input 9 volts directly to the board instead of going through the rectifier. That way I can actually see how much this is drawing, because I'm using my bench power supply. So I'm just gonna set it to like 9.4, and I'm gonna have a maximum draw. Let me start by just having 800 milliamps on. Yeah, and it actually draws 800 milliamps, and the voltage went down to 5.9. Let me set it to 1.8 amps then. Yeah, now it draws 1 amps and 9.4 volts. So yeah, that looks alright to me. And now what do we have on the board then? 4.87, that seems to be correct. That's normal at least. Okay, so it's just the power supply that's too weak. Gonna reverse what I did. So I removed the old thermal compound here, and just gonna add a little bit new. And then back with the regulator. I think it was this, it was upside down with the text. So. Well, now I just need to figure out how to get a bigger power supply for this. Need to look through my stuff. I inserted the chips again, and I'm hooking it directly up with 9 volts to the out of the rectifier, and I connected the TV. Let's see what happens. Okay, it actually detects a signal. So there is a video signal, but it is black. So what do we have from the voltage regulator? 8.8 in and 5.1 out. And some of the chips, check, yeah, 50 volts into that chip, and that's perfect. So I was looking through my stuff to find a suitable power supply. Then I realized I have a lot of these old Commodore 64 power supplies. It has 10, 11 volts AC output, and we're just going to use the AC part. The DC part will not be used. So I just made a little adapter for that. That should work. Okay, let's see now. Do we have the voltages we want? Yes, 5 volts exactly. So, okay. Now at least I have a suitable power supply for now. So now I can actually start diagnosing this board, find the real fault. So I just start by feeling the chips, if anything is hot or not. Oh my god, that one is really hot. It's 74 133. I think that's not normal. But still, it might not be that actual chip. It could be something else related to it. But I'm gonna start scoping a little bit, see if we have signals on the chips. Yeah, there's definitely activity on the CPU. It has a clock, looks nice. Obviously that was not the CPU, I'm measuring the VIC chip. I'm just used to the CPU on the Commodore 64 is up here, but this is the 6502, it's here. But I find no signals on the address bus and the data bus. It's all just high everywhere. But the CPU has a clock both in and out. That's the clock out, and that's in, so that looks normal. But take a look at this. Pins on the address bus, all just high. This is the data bus pins, nothing. All just high or low. No activity on the data bus. Well, since that chip is incredibly hot, I'm gonna remove it. There's clearly something wrong with it. That came out quite easily. Not really sure if I have a 133. I have to look. So what does the Chip Tester Pro tell us? 74133. That was a strange result. Usually it just tests the chip in just a few seconds. I don't know why this is just counting up like that. Oh, I had selected the 74133 plus, but there's a 74133 without a plus. Not really sure about the difference. The chip is okay, alright. What's wrong then? Why does it get so hot? So that was a dead end. Anyway, I'm soldering in a socket and gonna check if I actually have a 133. Maybe I can replace it after all, just in case. In case it is actually faulty. It might of course be the CPU that's faulty, since it's not doing anything on the address and data bus. But why this chip gets so hot, that's another issue. I mean, it might be normal, but I have never felt such a warm chip before, and if it gets that hot, it should perhaps have a heat sink. I looked through all my chips and I don't have a 133, so I just have to put it back and yeah, trust that it is still working. Alright, so I pulled out one of my working VIC-20s and I'm gonna run the diagnostics cartridge. I have one here. I'm just gonna try it first on the working one, just to see that it's configured correctly. This contains several other things, not only the diagnostics ROM. So yeah, let's see. I think it's set up correctly. There's some jumpers on that card. Yeah, it says serial bus bad, but that's because I don't have the harness in, but at least it runs. So let's check with the dead machine then. I'm thinking it might not do anything at all, but just want to test. Clean up the slot first. No, still dead. I checked all the three ROMs and they all appear to be good. They produce a CRC32 checksum, same value every time. So just to be sure, I read the ROMs in this program for the EEPROM burner, and yeah, you can see the text from the kernel ROM. It says press play on tape. So when there's no activity on the data and address buses, then nothing works on this machine. No chip can then operate. So I did test a little bit signals on this chip. I think this controls the bus, but most of the signals are just high all the time, except on this chip. That's some strange signal just hovering around 1 volt. That's just 2 volts. Let me show you. Yeah, so that's kind of strange. Very low signal and strange signal, and several of those pins are like that. So either there's something wrong with this chip, or there's something wrong with the signals that goes to this chip, because all outputs seems to be just high. Yeah, that chip is a bus transceiver, and yeah, it makes sense that it could be faulty and thus creating problems with the bus. So I'm gonna solder it out and test it. That one came out easily as well. Alright, so what do we have here? 74LS245. 245. Alright, it failed. It says pass 2-3 and then failed. Sometimes there can be a bad contact, so just test several times. No, that chip seems to be faulty. Hopefully that is it then. Now I just need to insert the socket and find a new chip. Okay, let's see if I can find a 245. I think I have one in this kit. Yes, 245. Just gonna test it first. It's from AliExpress, so I don't trust these chips. Yeah, that chip is good. Good. Alright, with a new chip in, let's see, do we get something? Nope. Still dead. So we have more issues then. Could obviously be some of the other bus transceiver chips. There are 3. No, it's the same bad signals on this chip as well, so that isn't from the chip itself, it's from something driving the chip. So I just have to take a look at the schematics, try to figure out the next step here. Still, this chip is very hot. There is something wrong there for sure. So after thinking a little bit more, I'm still suspecting this 74133 chip. Since it got so warm, even if it passed the test, it can still be faulty under load, I guess. So I found another VIC-20 board here, and I pulled out the 133 and inserted the socket. There, this one is working. So the chip is in now. Let's see, does this help? Yes. Well, or no. So, well, that's an improvement. Garbled screen, I guess that's better than black screen. So then that chip too was faulty. At least now the machine is running because it's producing graphics. So I'm pretty sure there's activity now on the data bus and the address bus, and yeah, this could very well be a RAM problem. There are no less than 8 RAM chips to test, and it's pretty hard to test them in the machine. But now maybe the diagnostics cartridge can help. Let's see with the diagnostics in. No. It produces some kind of output, but yeah, still it doesn't run. Produces different input each time I reset. Okay, there we have something. Alright, so there's more to do here, unfortunately. So no, that chip does not get any warm at all. So yeah, definitely was some fault with the chip. Let's see now, signals on the buses. Yeah, no, that looks perfectly normal. Just need to check all the lines and see that we have activity on every line. So I tested the address and data bus lines, and the data bus looks all fine, but on the address bus there is still some missing signals. And every address line from A7 and upwards are not active, so yeah. So I guess there's another faulty chip. I suspect maybe these 245s here. I said there were 8 RAM chips, but there are in fact 11, and they are all 1024 times 4 bits, so that is 5K, which this machine has. If I take a look at the schematics, yeah, in fact, those two 245s are transceivers for the address bus. So address line 7 is on UD8, and the other address lines upwards are on UE8. And that's those two. So I'm just as well gonna remove them and see if they are working as well. I mean, this one was not good, so something might have happened that took out those chips. These 2 chips, they really took an effort to get out, and yeah, hopefully they came out safely. I can't see any damage. I'm gonna test the chips, see if they are good or not. Alright, failed. No, that was okay after a little adjustment in the socket. But I mean, the 133 was tested okay, so how reliable are these tests? Let's test the other one. Oh, failed. Damn, those are good. Or are they? I mean, now it's really good in there. I'm gonna try with some new chips anyway. They might be on the border of damaged. New chips in, but still the same, so it wasn't those chips after all. I didn't actually test the address bus when I, after replacing those 245 chips. Yeah, it's still the same. But I noticed also on the RAM there's something wrong. I checked all the pins from one and looks like normal activity on most. However, pin 6 is flatlined and you can see there's something changing on the screen when I hit it with the probe. Kind of strange. Not really sure. It's on all those RAM chips here, but these down here are okay. Same pin there, and there's normal activity. So either there's some control logic chip controlling these RAM chips here that are faulty, or the RAM itself. But which chip then? I just need to study the schematics a bit more. We know that CA7 is not producing any signal, and it goes into the 245, actually 2 of those. No, that's CD. No, it's only going into the 245 and then it's out. Otherwise, the address bus from the CPU just goes down somewhere else. Can't see anything between. It comes in here, CA0 to C15, and that goes to the 6522 CA chips. I have taken that out, so it's not into the equation. Then it goes down over here to a 74 LS138 UC6, but that does not take in CA7. That one too, it's just for CA13, 14 and 15. And then the address bus goes over to the expansion port.